Okay, today we're going to quadratic functions. So quadratic equations. Again, in college algebra, basically we talk about expressions, how to simplify expressions, change expressions from one form to another form, then solving equations. Right. So now, this lecture is about solving a quadratic equation. So the standard form is this. You see the variable, we have x squared. So x squared makes this expression quadratic. That's the word quadratic come from. Means degree 2. Degree 2, polynomial of degree 2. So this 2 is a degree. Then we have linear. So bx plus c is a linear. And a, b, c here, just some numbers. Yeah. If we compare to this one, we see a is 1, b is -2, c is -15. And in quadratic, we require the number before x squared or the coefficient of x squared, a cannot be 0. Because think about it, if this is 0, ax squared would be 0, and we're left with bx plus c. But the bx plus c is called a linear. Yeah, linear polynomial degree 1, because x raised by first power. So to be called a quadratic, we have to have x squared term. So which means this a cannot be 0. All right, let's go back to this one, right? So to solve this quadratic equation, and this one we can factor because 2 factors of -15, -5, and 3 adds up to be -2. Okay, so we can factor x squared minus 5 minus 15 to be x minus 5, one binomial, then multiply by x plus 3, another binomial. Then because something multiplied by something in a factored form, this is by 0 property. If we have one factor, this factor can be any expression, and this factor can be any expression. If the product of those two to be 0, that means each one can be 0. So this is called the 0 property. Then we can, so this becomes linear. So each factor is linear. So we solve this linear equation, we get x equal to 5. So this one, we get x equal to -3. So we have two solutions. We have 5, we have -3 for this quadratic equation. If we plug in 5, we have 5 squared minus 2 times 5 minus 15, we see that equals 0. We plug in -3 squared 9, 9 minus 2 times 3, that's positive 6. Adding together is 15 minus 15, that's 0. So those two numbers are the solutions of this quadratic equation. But not all quadratic equations can be put in a factored form. So what happens if we cannot factor a quadratic equation? Let's see, if we have x squared, let's see, plus 2x minus 2 equals to 0. And we will not be able to put this in a factored form. Then we can do 2 methods. The first method is called a quadratic formula. Quadratic formula, we see x equals to -b plus minus square root of b squared minus 4ac divided by 2a. So where does this abc come from? It's from here. If we write the equation as ax squared plus bx plus c equals 0, and we solve x in that way. So let's figure out abc here for this one. So a equals 1, b equals to 2, and c equals to -2. So we just plug in ABC into the formula. So -2 plus or minus square root of b squared, which is 2 squared, minus 4ac, or 8 is 1, and c is -2. Divided by 2 times a, or a is just 1. Then we have -2 plus or minus square root. Now let's see, well, 2 squared, 4, minus 4 times -2, that's positive 8. So 4 plus 8, 12, of square root of 12 divided by 2. Remember, square root of 12 can be simplified because square root of 12 is the square root of 4 times square root of 3. That's a 2 radical 3. So this one we can write as -2 plus minus 2 radical 3 divided by 2. Then we simplify. -2 divided by 2, -1. 2 radical 3 divided by 2, that's just radical 3. So we also have two solutions for this equation. If we plug in -1 plus or minus the square root of 3 into x, we see the equation holds. But these two solutions are not like this. So in this case, we see the solutions are rational numbers. But in this one, because it's not factorable, but we use a quadratic formula to solve it, we see radical 3 is an irrational number. So we have irrational solutions. So those are rational numbers. If we have rational numbers as solutions, that means the equation can be factored. If it's not factorable, sometimes we get irrational solution. Let's say square root of 3 is called an irrational number. Why is it called irrational? Irrational means it doesn't really make sense to our brain. We can approximate square root of 3, but no one really knows what exactly it is. So keep like square root of 3. And square root of 3 just means some number when you square, you get 3. That's the meaning of it. Okay, that's one method if we cannot be factored. So let's see. So this called a factoring method. And the second called a quadratic formula. I want to talk about the third one. Formula. The third one, I'm going to erase something to write on this side. Called completing squares. So the third method is called completing a square. Let's see what does it mean. So I'm still using the same equation, x squared plus 2x minus 2 equals to 0. So we want to solve this equation using completing a square method. So what do? First, we want to move this number, this constant, to the other side. So we have x squared plus 2x equals to 2. Now, we take the number before x, 2, we divide by 2. So the numerator 2 is the coefficient of x, and dividing by 2 is always divided by 2. Well, then we get a positive 1. Then we're going to do this. We're going to plus this 1 squared on both sides. Equation, right? We add on both sides. The equation still holds. Then this side becomes x plus 1 squared. The other side becomes 2 plus 1, just 3. Then I square root both sides. When I square root, I get a plus minus 2 values. So I get, remember, square root cancel each other. So I have x plus 1 equals to positive or negative square root of 3. Then I move positive 1 to the other side, becomes negative, plus minus square root of 3. Two solutions. Now we check is exactly same as this one when we use a quadratic formula. So basically saying the mathematical principles behind it are exactly the same. But but we just call different methods. So overall, we have three kinds of methods to solve quadratic equations. The first one is factoring. If we can factor the quadratic equation, we would do that. If not factorable, or we don't know how to factor it, we use quadratic formula or completing a square. Okay, we're going to do more practice. Let's use quadratic formula to check this one. Oops. So we know this one previously, x squared minus 2x minus 15 equals 0. We factor as x minus 5, x plus 3 equals 0. Just in the previous page, right? So we got x equals 5 and -3. We have two solutions, remember. So this is from factoring. But now we're going to use quadratic formula for this one. So first we identify a is a number before x squared, which is 1. B is a number before x, which is -2. And C is the constant, which is -15. So then we just plug in to the quadratic formula. Negative b, -2, plus minus b squared, -2 squared, minus 4 times a, 1 times c, -15. Then we do the calculation. So -2 squared is 4, -4 times -15, positive 60, 60 plus 4, 64. So -2 become positive 2. So 2 plus minus square root of 64 divided by 2. Well, square root of 64 is 8. Okay? So 2 plus minus 8 divided by 2. 2 plus a is 10. 10 divided by 2, that's 5. 2 minus a, that's -6. -6 divided by 2, that's -3. Right? The solutions are the same. So it doesn't matter which method we use. The solution should be the same. Now let's practice this. So let's use a quadratic formula. So first we need to figure out A, B, C. A is a number before x squared, which is 1. B is a number before x, which is 1. C is a number all by itself, which is 4. Then x equals to -b, -1, plus minus square root of b squared, which is 1. 1 squared is 1, minus 4 times a is 1, times c is 4, divided by 2 times a, which is 2 times 1. So do the calculation, we have -1 plus minus square root 4 times 4, 16, 1 minus 16, that's -15, divided by 2. So when we divide, we divide by -1 divided by 2 plus minus square root of -15 divided by 2. Remember from yesterday, talk about imaginary numbers. So negative square root of -15 is square root 15i. We can put an I behind or I up front, right? Because square root of -1 is I. So we write this as -1/2 plus minus square root of 15 over 2. We can put the I up front or I in there. So this is called a complex number. This versus real number, complex numbers, right? With this I defined as the square root of -1, and the I squared equals to -1, I raised by 3 equals to I raised by 4 equals +1. See, those are two beautiful numbers, right? I is imaginary, but somehow when we square it, it becomes real number. When we raise by 4, it equals to 1. So I is a cyclic. All right, now let's see. excuse me. This is the second one. So the first one, we have two complex solutions, right? We have two complex solutions. Let's see second one. Figure ABC, A equals 1, B equals 4, C equals to positive 1. So x equals to negative b, negative 4, plus minus square root of b squared, 4 squared 16, minus 4 times 1 times 1, or just 4. Divided by 2 times 1. Well, then we have negative 4 divided by 2, plus minus square root of 16 minus 4, that's 12, divided by 2. Negative 4 divided by 2, negative 2, plus minus, remember square root of 12 is 2 radical 3, divided by 2, that's negative 2 plus minus square root of 3. So the second one, we have two irrational solutions. Now let's see 3. A equals 3, B equals negative 2, C equals to 3, x equals to negative b, negative and negative 2 become positive 2, plus minus negative 2 squared is 4, minus 4 times 3 times 3, 4ac, a3, c3. Divided by 2 times a, 2 times 3. So we split 2 divided by 2 times 3, plus minus square root, let's see, 4 times 3, 12, 12 times 3, 36, 4 minus 36, negative 32, divided by 2 times 3. So that equals to those two simplified as we get 1/3 plus minus, well, square root of 32 is square root of 16 times square root of 2. That's 4 radical 2. So plus minus 4 radical 2 divided by 2 times 3. So we can simplify 4 with 2. So we get 1/3 plus minus 2 radical 2 divided by 3i. So this one we have two complex solutions. Okay, 4, let me change my color. Let's figure out A, B, C. A equals to 12, B equals to negative 4, C equals to 5. Now we plug into the formula. Negative and negative 4 is positive 4, plus or minus square root of negative 4 squared 16, minus 4 times 12 times 5, divided by 2 times 12, because A is 12. So this we get 4 divided by 2 times 12, plus minus square root. So we have 12 times 5, we can do 12 times 5, 60, then times 4, 240. So 240 minus 16, that's a 4, 2, so we get negative 224, divided by 2 times 12. Well, 4 goes into 12 3 times, right? So the first term become a 1 over 2 times 3, which is 1 over 6, plus minus, well, let's see 224. 224. We divide by 2, we get a 1, 1, 2. We divide by 2, we get a 5, 56. We divide by 2, we get a 28. We divide by 2, we get a 14. We divide by 2, we get a 7. How many 2's? We have 2 squared, which is 4 squared. So 4 squared times 14. So basically it's 16 times 14. Okay. So square root of negative 224, we can do I square root of 16 times square root of 14. That's I 4 square root of 14. So putting here, so we have 4 square root of 14 divided by 2 times 12. We can put the I in this place. So 4 goes into 12 3 times. So in the end, you get 1/6 plus minus square root of 14 divided by 6. Because 2 times 3 is 6. So we have two complex solutions. Okay, that's it. That's it for lecture 17.